Welcome to the Applied Physics Laboratory. Now the experiment is transistor characteristics. The aim of the experiment is to study the input and output characteristics of a transistor and also to determine the input resistance and current amplification factor. This is the apparatus. This is basically a BJT transistor, common emitter configuration. This is the transistor, this is the emitter, base and the collector. This is related to input and this is related to output. Coming to the theory, this is how the transistor looks like. There will be three terminals, emitter, base and collector. Here the input is applied across base and the emitter and the output is measured across collector and the emitter. So emitter is common for both input as well as output. So it is also called common emitter configuration. This is how the configuration looks like. Here we have VBE, that is the input voltage. We have the IB, that is the input current. We have the IC, that is the output current. And VCE is the output voltage. Coming to the input characteristics, in the input characteristics, we are going to keep VCE as a constant, that is output voltage will be kept to constant, say for example 3 volts, and we are going to vary the input voltage and we are going to measure what is the input current. This is input characteristics. Coming to the output characteristics, in the output characteristics, we are going to keep the input current as constant, say for example 75 microamps and 100 microamps, and we are going to vary the output voltage and we are going to note down what is the output current. That is called output characteristics. Coming to the circuit connection and conduction, this is the experiment. Here we have a transistor. Transistor is kept here. These two knobs can be used to vary the output voltage. This is the transistor. In this transistor, so how do you identify what is emitter, base, collector? Hope you can see the notch over here. This is the notch. Near to the notch, the terminal is called emitter and remaining are base and the collector. Near to this notch is called emitter. Now let me put the emitter back to the position. Next, in order to do the circuit connection, please note that wherever there is a line, it is already connected. Where there is no line, we have to do the connection. P to A no line, Q to D also no line, F to T also no line, G to S also no line. We have to complete the circuit. Connect P to A, then G to D, then F to T. This completes the circuit. Now we are going to study the input characteristics first. So we have to keep VCE as constant, that is output voltage should be kept constant. So in order to do that, let me connect VCE to voltmeter. VCE should be connected to the voltmeter. Positive should be connected to positive of the voltmeter and negative should be connected to negative terminal of the voltmeter. Now VBE we are not going to use now. We need to use the input as well as output current. Let me connect input current to the ammeter, that is microammeter, positive to positive and negative to negative. Milliammeter, positive should be connected to positive and negative should be connected to negative terminal. Negative should be connected to negative terminal of the milliammeter. Now turn on the instrument. In order to study the input characteristics, first set the VCE value to any one constant value. We have two knobs, one is fine, other one is coarse. By using coarse knob, keep the VCE value to 3 volt. That is output voltage should be kept it to 3 volt. Once you set it to 3 volt, you are not supposed to touch that coarse or fine knob. So it is set to 3 volt. Now I have to vary VBE, that is input voltage I am supposed to vary. Since all the ground connection are negative, I don't have to shift the negative terminal, only the positive terminal I'll connect from VCE to VBE. I don't have to shift the negative terminal. Now I should vary the input voltage and I should note down the input current. Input voltage versus input current. Milliammeter we are not going to use in the input characteristics. I'm supposed to vary the input voltage and I should note down what is the input current. Go from zero point 0.1 to zero point 0.7 or zero point 0.8. For each value with a difference of 0.1, note down what is the input current. Say for example, if for zero point 0.6 it is 19. Just change the polarity because it was showing negative. Yeah. Now 0.65 it is showing 19. 0.1 to 0.7 you are supposed to vary. Now coming to the output characteristics. For output characteristics, you are supposed to vary VCE and note down IC, but IB should be kept constant. That is, IB is nothing but that is the input current should be kept to constant. Say for example, 75 and 100. Now I'm going to keep it to 100 first, then I'll go to the 75 microamps. Keep IB value to 100 microamps. Then vary output voltage and note down output current. What is output characteristics? Keeping input current to be constant and vary the output voltage, note down output current. The input voltage, that is 100, 105 to showing, it should be kept to 100 carefully. Now vary the output voltage, it go from 1 to 8, keep it to 1.1, note down the output current, so go up to 7, go up to 7. Now once you are done with 100, again keep the input current to 75 microamps and repeat the same thing. That's all about the experiment. This is the tabular column. We have input characteristics. Output voltage, as I told you, is kept to 3 volt. You are supposed to vary input voltage and note down the input current. This is for the output characteristics. You have to do two readings here. Input current kept to 75 and input current kept to 100 microamps. You are going to vary output voltage, note down output current for 75 as well as 100 microamps. This is you have to plot the graph IB versus VBE and you are going to get the points over here. From that you have to determine the input resistance. Here you are not determining the slope. So if I say for example, if I call this as ABC, slope becomes AB by BC, but you need the resistance. According to Ohm's law, we have V equal to IR. I need resistance V by I, but V is in this scale, x-axis. So once you are determining the slope, take the inverse of it. Then you are going to get the input resistance, that is 1739 ohms. That is the input resistance. Coming to the output characteristics, you have to plot the graph of IC versus VCE, then extrapolate the points, and once you extrapolate this point, this 12 you're going to reach, here you're going to reach 16, that is your IC1 and IC2. This is for 75 microamps, this is for 100 microamps, that is your IB1 and IB2. By using that, you are going to calculate what is the current amplification factor. Input resistance, just now we have calculated in the graph itself, VB by IB, and current amplification factor IC2 minus IC1 divided by IB2 minus IB1. IC2, IC1, you got it from here, that is 12 and 16. IB2 and IB1, this is for 75 and 100 microamps. From that you will get the current amplification factor. Current gain, this is beta just now calculated, divided by 1 by beta, you will get approximately equal to 0.9. Thank you.